Good morning, ladies and gentlemen, boys and girls, friends and neighbors, whatever the case may be. Good morning, good afternoon, or good late evening. This little video is going to be about polynomials in factored form. Polynomials in factored form are going to be easier to give a rough sketch to than other polynomials in non-factored form. Thus far, we have only talked about polynomials in a non-factored form. So let's jump into what in the world is a polynomial in factored form. Well, here, just give you a brief example. Here's a polynomial in factored form. This polynomial is factored. We have the factors x minus 3 times x plus 1 times x plus 4. To get a sketch of this particular polynomial, we're going to go through the steps to sketch this polynomial. We are not going to multiply that polynomial out. However, the first step is going to find the first term of that polynomial, which is going to be the power function. I will go through this on the next slide, how to actually find that first term without multiplying the entire polynomial out. So the first thing we're going to do is find the first term, i.e. another term for the first term is the power function. Second thing we're going to do is we're going to find the last term. The last term we're going to find out is going to be the y-coordinate of the y-intercept. This is going to be easy to see as well. So we're going to find the last term. It's going to be easy to do. And then the next step of analyzing the graph of a factored polynomial is going to be find the x-intercepts. This is going to be super duper easy, finding the x-intercepts of a factored polynomial. We do not need a graphing utility for this. We'll be able to just to look at the factored polynomial and see them. So we're going to find the first term, we're going to find the last term, we're going to find the x-intercepts, and then the last thing we're going to do is we're going to determine the end behavior. And how are we going to determine the end behavior? We're going to use the power function. We're going to look at the degree of the power function and the first term of the power function to decide whether the graph starts positive, starts negative, ends positive, or ends negative. We had 2 videos over the end behavior of a polynomial thus far. So then after those steps, we're going to make a rough sketch of the graph of the polynomial. So let's zoom out here a minute. Let's look at the entire page. And so those are our steps. We're going to take a factored polynomial. We're going to look at the first term, i.e. the power function. We're going to find the last term. We're going to find the x-intercepts. We're going to determine the end behavior, and we're going to make a sketch of the graph. And keep in mind, what's really nice about these videos, at any time you can pause the video if you want to take notes. And you can put these notes wherever you like, wherever you desire. I'm going to have a couple follow-up questions for you to do as an assignment. Okay, so let's do these 5 steps with this particular guy right here. Let me zoom back out so we get to where we can see each step. And I'm going to go to the next step. It's in the next slide, sorry. And I'm going to look at the same factored polynomial. I'm going to find the first term. To find the first term, you're going to act like you're going to multiply it out, but you're not going to. You're just going to look at the first term of each factor. And if you notice, I have an x is the first term, so the power function, or the first term, is simply going to be x cubed. So f of x is going to be x cubed. We don't care what's in the middle. That's what's really nice. And this, note, ladies and gentlemen, is the power function, x cubed. That's going to determine the end behavior of this particular polynomial. The next thing we're going to do is we're going to find the last term. So we don't care what's in between. So in between, we're just going to put these 3 ellipses to know that, to make a statement that there is something in between the first term and the last term. And in like manner, to find the last term, all we're going to do is we're going to, let me get a good color here, we're going to look at the last term of each factor. And this is going to be negative 3, 1, and 4. And we're going to multiply those three numbers together. So negative 3 times 1 is negative 3, times 4 is negative 12. So the last term here is negative 12. So if I were going to multiply that polynomial out, which I'm not, it would be x cubed plus some x squared plus some x minus 12. We only need, this is the last term, the power function, or the power function right here. This is the first term. And this guy here is the last term. And what is the last term? The last term is the y-intercept. So this is the y-intercept. Y-intercept here is going to be 0, comma, negative 12. So that's where it's going to cross the y-axis at. All right, so and this is the last term, is the y-intercept. And we can see that easily because if I just evaluated that function at 0, because I know y-intercepts, y-intercepts happen when x is 0. Looks like it's a bad 0. If I put 0 in, oh, look, you can see an eyeball. Look at it. Oh, that's funny. Anyway, if you put 0 in, you're going to get 0. 0 minus 3 is negative 3. 0 plus 1 is 1. 0 plus 4 is 4. And you would get negative 12. If you did that, yes, you indeed would. Okay, so let's go to the next step and find the x-intercepts. This is what's really cool about a factored form. X-intercepts happen when y is equal to 0. Well, if you remember about quadratics, when we were finding zeros of quadratics, if they were in factored form, it's really nice because when is this guy 0? I'm going to write this down here. When is this guy 0? Well, that's going to be 0 if x is equal to 3, or when x is equal to negative 1, or when x is equal to negative 4. So you just look at where each factor is going to be 0. This is easy to determine where that's 0. X equals 3. Easy to determine where that is 0. X equals negative 1. Easy to determine where that's equal to 0 at negative 4. So here are your three x-intercepts. Let's see, how can I write these? I think I'll just write them in blue. It's going to be 3, comma 0, negative 1, comma 0, and negative 4, comma 0. What a lot of students do is they just let the x-intercept be negative 3, 0. No, no, no. It's what makes that 0. What's going to make that 0 is 3. What makes x plus 1, 0? Negative 1. What makes x plus 4, 0? Negative 4. What's x going on? Well, I want to storm one. No kidding. Okay, so here's my three x-intercepts. I have three x-intercepts. So now I have the first term, I have the last term, I have the y-intercept, and I have the three x-intercepts. Now I'm going to look at the end behavior of this rascal, and I'm going to look at the end behavior by looking at this power function, x cubed. So the degree is 3, and this is a review. The degree, if I can smell degree. The degree, if I can smell, again, I said it, that's funny. If I can spell degree, the degree is 3. The leading coefficient, and I'm just going to abbreviate that LC, is equal to 1. That's that 1. You really don't see that 1, but there is a 1 there. You just don't see it. So the leading coefficient is 1. The degree is 3. So this 3 is odd, and this 1 is positive, greater than 0, positive. And if you look at your notes from yesterday, what does that mean? If the degree is odd and the leading coefficient is positive, this graph starts negative. This graph starts negative and the graph ends positive. Starts negative, ends positive. And we do want to get used to writing these end behavior statements. So what does start negative mean? Start negative means as x goes to negative infinity, the function goes to negative infinity. What does end positive mean? It means as x goes to positive infinity, the function goes to positive infinity. So what I mostly want you to know right now is this part of that end behavior, where it starts, where it ends. This is something that we're going to work on over the next week or so, making these statements as x approaches infinity, as x approaches negative infinity. So what's the only thing left to do, and I'm going to zoom out again so we can see everything that we've done. I might be able to do it with 100%. Yeah. So I found the y-intercept. I know the power function. I used it to find the end behavior. I have the y-intercept. I can graph that. And I have these three x-intercepts. So I'm going to make a rough sketch of this polynomial knowing that fact. So I'm going to zoom out here. And let's see here. I'm going to scroll down. I'm going to extend my page. And I'm going to come up with a couple axes. I'm going to come up with the y-axis, the x-axis. And now look what I'm going to do. I'm going to plot everything that I know. Well, I know that there had a y-intercept of 0, negative 12. 0, negative 12. I had these three x-intercepts. What were the three x-intercepts? 3, 0. And we're just going to estimate where these are. This is 3, 0. I had two negative x-intercepts. I had negative 1, 4. And let's see here. I can put him down here, I guess. Negative, crap. Negative 1, 0. Sorry. A big mess out of that, didn't I? Negative 1, comma 0. And then I had this other guy right here, negative 4, comma 0. Negative 4, comma 0. I know I barely see that. And now I know the end behavior. And the end behavior starts, this graph is going to start negative. I'm going to do the graph in, oh, let's do the graph in. So it's going to start negative. Get out of there. Get out of there. It's going to start negative. I need to extend my page a little bit. The graph is going to start negative, and it's going to end positive. And the other thing that we need to know is that polynomials are continuous. They're continuous and smooth. Smooth means there are no sharp turns. They're turns, but they're smooth turns. But it is continuous. So it's continuous, then the graph has to come up here. It's going to go through that x-intercept. It has to turn nicely, go back through that intercept, come back here, go through the y-intercept, come back here, and that's a rough sketch, and it is a rough sketch of that polynomial. And keep in mind, I'm not covering up those x-intercepts, but they would go through that. So that's a rough sketch of that polynomial in factored form. Okay, so I'm going to zoom out, and we're going to do another example here. Zoom out, get the whole entire page in there. Okay, so that's a rough sketch of the polynomial x minus 3, x plus 1, and x plus 4. So let's do another example. Okay, so let's zoom back out. Let's go to 200%. Let's go to the next. Now here's another one in factored form, another example we're going to go through. And the only problem here is this one factor is squared. And what does that squared mean? Well, that means x minus 2, x minus 2. And that's going to determine something very special about this particular graph. But let's go through it. So I have x plus 5. I have x plus 1. I have x times x minus 2, x minus 2. So I have two factors of x minus 2. And if we remember about quadratics, when I have a factor that's squared, the graph of that quadratic bounces. And the same thing's going to happen here. This thing is going to bounce at 2, but and we'll discuss that as we get there. So if I find the first term, I'm only going to look at the first terms again. It's going to be pretty simple. Let's not look at that one. Get that guy out here. Let's look at these. We're going to look at the factored ones. Okay. So I have x times x times x times x. What's the first term? You bet it. It's going to be x to the 4th. That's the power function. What's the last term? So I'm going to go again. I'm not going to worry about what's on the inside. I'm going to find the last term right here. And if I look at the last term, I'm going to multiply all of the last numbers in your factors. I'm going to multiply 5 times 1 times negative 2 times negative 2. Negative 2 times negative 2 is 4, times 1 is 4, times 5 is 20. So the last term is 20. Think about that, how I got that. It's going to be 5 times 1 is 5, times negative 2 is negative 10, times negative 2 is positive 20. So that's the last term. And that's going to give us the y-intercept. So the y-intercept is going to be 0, 20 is the y-intercept. I'm going to simply look at that, and I'm going to look at the x-intercepts now. What are the x-intercepts? The x-intercepts have y of 0. When is that guy going to be 0? At this point, you should be able to look up here. When is x plus 5 0? When is this guy 0? That's going to be 0 if x is negative 5. So that your first x-intercept is negative 5 comma 0. Where is x plus 1 0? That guy is 0 when x is negative 1. And where is x minus 2 0? X minus 2 is 0 at 2. And this is called, since it has a factor, since x minus 2 is a factor twice, that's called a double 0. This guy is a double 0, or more formally, a double root. A double root or a double 0. Double root. And what happens? The graph is going to bounce. This is going to give us a bounce off of the x-axis. This is a bounce. Whenever you have a double root, it's a bounce. I'm going to give you a couple. I'm going to give you 3 problems to do, and one will have a bounce. So let's look at the end behavior. And so to get the end behavior, let's zoom out here a little bit. I'm going to look at the power function. The power function x to the 4th. This has a degree of 4, which is even. And I'm looking at my notes. The leading coefficient here, again, you can't see it, but it's 1. And 1 is positive, so the leading coefficient is 1, which is greater than 0 is positive. What does that mean? That means that this thing is going to start positive, and I'm looking at my notes, and it's going to end positive. Start positive and end positive. And again, I'm going to write a statement about the end behavior using the approaching method as x approaches. So what does this mean? This means as x approaches negative infinity, because that's where a graph starts over there to the next, to the negative, f of x approaches positive infinity. And what does this mean? End positive? That means as x approaches positive infinity, the function approaches positive infinity. So now I'm going to take all that information and I'm going to make a sketch. So I'm going to zoom out. I'm going to scroll down, make a grid. And let's sketch our rascal in red. It's going to start positive up here. It's going to end positive right here. It has an x-intercept. This graph, the graph has an x-intercept of negative 5, 0. I don't know what happened here. There it is. Let's make this guy. Okay, let's, I don't know what I did there, but anyway, it doesn't matter. So this guy here has a x-intercept of negative 5. and -1 and -5, -1, and an x-intercept of 2. But where is the y-intercept? Where is the y-intercept? Well, the y-intercept was 0, 20. So it has a y-intercept way up here. Knowing that the graph is continuous, knowing that the graph only has 3 x-intercepts, we're going to follow that. So if the graph has got to come down here, it doesn't bounce at -5. I don't know why my line is going squiggly. I don't know. Maybe it's my wrist. I don't know. And then it jumps up here, goes through that guy, comes down here. But look what has to happen. It has to end up over here. It can't cross the x-axis. So what it does is it bounces at that 2. So that's a rough sketch. There's a bounce at 2. It bounces on the x-axis at 2. This is your y-intercept of 0, 20. This is your x-intercept of -1, 0. And this is your x-intercept of -5, 0. And that's a rough sketch of that factored polynomial. What I'm going to do is look at the whole page now, the entire page, so you can make a copy of that. So that's a short 20-minute video over giving rough graphs of polynomials in factored form. I will see you soon.